Welcome back. Here's the second part of this little instruction video. We're going to keep on using the fundamental counting principle, but we are going to have something here called restrictions. And so when you're solving problems that include restrictions, it's important that the restriction is dealt with first, and you're going to see why in just a minute. So the first one I want to look at here is one that has how many odd numbered 4-digit numbers can be formed. Okay, now this is a little bit of a restriction. You'll see why. 4-digit number, I can break this apart into 4 subtasks or 4 stages, and I have them arranged like a number. And I want you to focus on the last little bit here because this one needs to be odd. Now, in order for it to be odd, it has to be 1, 3, 5, 7, or 9. Only those numbers. So that really gives me 5 ways that can be chosen. Now, it's important to note that this isn't the number 5. This is the number of ways. Now, this can confuse people a little bit. Your brain is used to looking at this and thinking of it as a number, but it's not. It's a fundamental counting principle where it's thinking about the number of ways. Now, the next restriction that we need to worry about, and this isn't totally obvious at first, but it's that this first number cannot be 0. And the reason why is if we had 0 as our first number, then it would be a 3-digit number, not a 4-digit number. And so there are going to be 9 different possibilities if we're not allowed to be 0, because we could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. 9 different possibilities. So I'm going to put 9 there. And then for the last 2 stages, I have 10 choices because I'm allowed to be 0 if I want. And this one too could also be 10. And so the fundamental counting principle says that the total number of ways is simply the product of these 3 things. And so we've got 9 times 10 times 10 times 5. So 9 times 10 times 10. Of course, sorry, I'm blanking out here. 4,500 ways that this could happen. Okay? Now, we're going to add some restriction to this. More restriction. The next one has the same thing. The odd digits, 4 digits. And here's the extra restriction, that we can have no repeating digits. Now, at first, this might not seem different, but here we go. So, same thing before. This last one has to be odd, and so there's going to be 5 ways to do that. Now, this isn't the number 5, it's just 5 different ways that we could pick. It could be a 1, it could be a 3, it could be a 5, 7, or a 9. And then we're going to head out to the front here. This can't be 0. But there's an additional thing because of this no repeating digits. Now, we've already chosen 1 digit in our first stage, so instead of 9, I only have 8 ways to choose that number. Here's an example. The last number might have been a 1, so now I don't have a 1 and I can't have a 0, so there's only 8 remaining. Okay, now as I move to the second stage or third stage, I've already used 2 numbers. So I don't have 10 choices possible. I only have 8. And then for my final stage, I've used 3 numbers. And so I only have 7 choices. Okay, now the fundamental counting principle says the same thing as before, that in order to find the total number of ways to do this task, I just simply need to multiply them all together. And so 2,240 ways. So this added complexity here of having no repeated digits definitely reduced the number of ways that we can do this. All right, let's move on. We're going to do the same thing, except this time we're going to make sure that we are having even 4-digit numbers. So I'll start the same way, set up some 4 stages. say that this last one has to be even, and so our thinking is a little bit different. Okay, this could be 0, it could be 2, it could be 4, it could be 6, 8, and I guess that's it. 5 different ways. The front is the same, this can't be 0. And so 8 different ways. And now even digits, I'm not saying, sorry, not 8. 9 different ways, because it just can't be 0. And then the next one is 10 and 10. Now the reason why this is just like the first one is because I don't have any restrictions about repeating digits. And so, of course, 4,500 ways. Okay, but here's a really interesting next step. If I look at the fourth one, I've got how many even 4-digit numbers can be formed with no repeating digits. This one's very different, and it might not be obvious to you at first, but I want you to imagine for a moment that in order to make this one even, that I chose 0. This is a special case because if I've chosen 0 and I'm not having any repeated digits, so I can say there's only one 0. Now when I move to the front, it can't be 0, but the 0's already been removed, and so really there's 9 choices here. I haven't repeated. I've got 0 in the front, in the last spot, and then one of the 9 remaining numbers in the front, and then I've used 2 of 10, so 8, and then 7. And so 9 times 8 times 7, and there's 504 ways to do that. Or we could have this other case, and that's where my choice in the back does not include 0. In other words, it's 2, 4, 6, or 8. Only 4 ways to do that. And then when I prevent not 0 in the front, I'm not allowed to use 0, and I'm not allowed to use the number that ended up in the back spot. So there's only 8 ways. Now I've chosen 2 numbers, so 8 and 7. And so this would be 1,792 with this or word in between. And what we're going to learn is we're going to get our brains to think of or as being addition and as being multiplication. So what this means here is, if I head over here, is that the number of ways is 504 or 1,792, and that gives me 2,296 ways. 2,296 ways. Okay, slightly different than the odd 4 digits, which have no repeating digits, because of this funny little thing with the 0 in the back here. This 0 is really changing, adds another case because of its interaction with the choice for the front letter. Okay, so I've got a couple notes here. One is that numbers are made up of 10 digits, not 9, because 0 is also a digit. And then, assuming no restrictions or repeating digits, then we assume there's no restrictions if there's no restriction mentioned in the question. And the last thing I think is worth remembering, you might want to highlight it for your future dumber self, is that even numbers which have no repeating digits have to be solved using 2 separate cases. Okay, good luck trying this stuff out.